Hello everybody. Today we are going to discuss about oxidation states. Before we start, we need to explain or define two crucial terms uh, that we need to know in order to understand the oxidation states. Those terms are in pretty much way the similar and sometimes a bit confusing. Valency and the oxidation states. Valency presents a number of electrons that atom has in its outer shell, while the oxidation state presents exactly how much of those electrons has atom either gained or lost. For example, since the electrons are negatively charged particles, if some atom gains electrons, its oxidation state will be negative, and if some atom lost electrons, its oxidation state will be positive. First of all, I'm going to present you here atoms that in vast majority of its compounds are always in same oxidation state. Hydrogen is always +1, oxygen is -2. The elements of first group periodic table of the elements, here is presented acronym for periodic table of the elements, PTOE, are +1 charge or oxidation state. They are also called alkaline metals. The elements of second group of periodic table of the elements are in +2 oxidation state, and here we have aluminum, which is +3 oxidation state. So why did I tell about these elements? Because in order to calculate the oxidation state of some element that is not always presented in the same oxidation state, you need to know, in most cases, you need to know the oxidation state of the other elements that are in vast majority of its compounds the same. For example, here we have some rules of the oxidation states that you need to know. If the atoms are presented as single atoms, or the elements, or in elementary states, their charge is always 0, or oxidation state is always 0. And it also applies for molecules that are consisted from the same atoms, from the atoms of the same elements, like hydrogen, oxygen, chlorine, and so on. And now I'm going to show you how to calculate particularly oxidation number or the oxidation state for any given element within its compound. Here we have some compounds, some salts, some bases, some acids presented here. For example, when it comes to sodium chloride, you have sodium atom, which has charge +1, as we said earlier, because it is its first group of periodic table of the elements, and chlorine atom, which is here -1, because the overall charge of each single compound or molecule has to be 0. Here we have some examples of acids and calculating how to calculate oxidation state of each single element inside those acids. For example, here we have hydrogen chloride, hydrogen sulfide, nitric acid, sulfuric acid, phosphoric acid, and some other. So, as we said earlier, the overall charge of each compound has to be 0. So, first we will write down the oxidation states of the elements we already know. For example, here in nitric acid we have hydrogen, which is +1 oxidation state, and oxygen, which is -2. And since we have 3 oxygen atoms presented in nitric acid, we have to multiply that number by 3, and so we have -6 overall charge of oxygen in nitric acid. So the only unknown charge here is nitrogen, and we are going to calculate it by this mathematical equation. So +1, which is hydrogen, plus x, which is unknown charge of nitrogen, -6 equals 0. And here we have calculated the overall charge, or the particular charge, or the oxidation state of nitrogen atom as +5. And so we can do the same for the other acids presented here using the same method, or for salts like sodium sulfate or magnesium sulfate. Also, I have prepared for you some homework. You can write down in comments down below the solutions of this homework for some acids presented here, like sulfurous acid, carbonic acid, perchloric acid, or potassium permanganate. You have to calculate oxidation numbers of each atoms presented in those compounds. So if this video was helpful to you, please don't forget to hit the like button and subscribe to this channel. And for anything that has been not explained to you, please leave comment down below, and I'll try to answer it on your question. So thank you very much.